So CJ from Stripe, welcome. Thanks for joining us today.
Awesome. Thank you. Thanks, Arno. That was a great tee up because we're going to talk about how Stripe lands API features, and we use the Open API spec a ton. So we should be able to go into quite a bit of depth, and I'm hoping to just show you kind of the interesting parts of how we land API features, because I think it would take a long time to go through the entire process. But yeah, super excited to just talk about the high level and some of the really interesting details. So for the last, maybe 5, 6, 7 years ago, I worked at a product company doing tons of API integrations, so integrating with other people's APIs. And we were building this big application. It was built on Django. The front end was Angular. And we were using the Django REST framework as just this tool to build these internal APIs that we were consuming as a very small team. And we talked to users, and users said, oh, we want to interact with your application using an API. And so what we did as this super small, scrappy startup is we were like, okay, well, our internal implementation isn't the greatest. We don't want to just make that public. So we did, we sort of just put some lipstick on a pig and made some new API endpoints, cleaned it up a little bit, and shipped it, and hoped that that would work out. And you know what? It actually did work pretty well. We had some people integrate, and whatever, it was fine. But the first few people that we talked to, of the first people we talked to, one of them was like, well, why don't you just expose like a GraphQL endpoint? We're like, okay, well, maybe our slapping lipstick on a pig isn't going to work for everyone, and maybe this GraphQL thing is the new hotness. But the moral of the story is that like that was a really, really naive approach to building an API. Just like take your internal one, change some names, and then like that becomes your external one. Fast forward a little bit, I started at Stripe about 3 years ago, and there's some really, really interesting things that we do that I think would be really helpful for the industry and for you folks if you're thinking about building what we're calling API first. Inside of Stripe, we would call it developers first. We're like building for developers, and that's what we're excited to do. If you're not familiar with Stripe, we are building economic infrastructure for the internet. We build APIs to accept payments, make payouts, and generally let businesses manage their entire existence through APIs. Has anyone integrated with the Stripe API before? Yes. Are you? Do you remember which API version you were on, or what year it was in? Not sure what the version was. So it turns out that the Stripe API has been around for like 10 years. And even if you integrated 10 years ago, your integration should still continue working with the same endpoints and the same everything. And we'll talk about that in a second. There's a problem with that. And that's that we don't actually like fully deprecate or remove anything. We will release an API. And if you integrate with that API today, it should just work forever. This is something that I wanted to just raise as a red flag, something that you want to consider as you're building your API. Like, don't do this and don't make this promise up front, because this makes it really, really, really challenging to evolve your API. And every single time you add a new feature, you have to go back and consider every previous API version when you're implementing, because you don't want to break someone who integrated in 2011. And maybe you want to add some new feature today that might actually have impacts for someone from 2011, and you're trying to maintain basically the code path for all of those different integrations. So I actually wanted to focus mostly today on this step of the release cycle for API features. This release step is pretty fun, and we do some cool stuff that I think is kind of interesting. But first, let's talk about talking to your customers. So if you've been in startups or been in we're in the Valley, so you go talk to your customers, get some feedback, iterate on that feedback. That's how you build these huge businesses, and they're super successful and whatever, right? But it really is true. And there's this new term. I think it was there was an article on UIE that was just linked to by Lee Robb. So Lee Robb runs developer experience at Vercel, and it talks about this concept called exposure hours. Exposure hours is like the number of hours that your team is spending with customers. So the amount of time that you're spending with developers and understanding how they are going to integrate against your API can have like a really outsized impact on the quality of your developer experience, on the quality of your API, on the choices that you're making for your business. So this, for us, is a really, really important thing. So this is, I wanted to get like super tactical and give you some tips and tricks. Inside of Stripe, we have this culture where we want to get in front of as many customers as possible and talk to as many people as possible. There is this thing called the Collison installation. This is when the founders were first starting Stripe, they would go to all of the YC companies and sit down next to them and implement Stripe into their application with them. They would just like go sit down and pair with them. And this has been something that has been a really important aspect of the way that we've built APIs for a long time. Here's a way that you can do it, right? Just teach product teams to build that muscle of reaching out and asking to talk to users. So this was just a couple days ago. I, as a developer advocate at Stripe, interact with tons of devs and tons of users, going to conferences, hanging out on IRC, on Discord. You know, we're in all of these places on Twitter. And so oftentimes product teams might feel a little bit removed. And so as advocates, we can kind of act as connectors to developers in the industry back to the product teams. Other times we'll just send emails out to the user base and ask for folks if they want to participate in maybe a UXR study. So UXR stands for User Experience Research. I just want to kind of like give a breakdown of an example doc that we would output for one of these UXR studies, just so you can kind of get an idea of the type of output that you might create. Also, as part of these UXR, and to increase those sort of exposure hours, we also video record all of these walkthroughs with devs who are trying to build something on the Stripe API. So maybe they're trying to go through and add some feature to their treasury implementation where they're trying to store some funds in some financial account. We want to watch that whole process. Product teams are going to go back and think about what did devs run into? What were they trying to solve? What kind of issues did they run into? And how did that impact their choices? So video recording those sessions can be really helpful. So just generally on this next step, right, in the design and review step, design and review of an API is really important because designing an API is super hard, especially when you get to a scale like Stripe's. And so every single API change that we release, we're trying to consider how is this going to impact all those previous versions? How is it going to impact webhooks, connect, cross-border payouts, different currencies, local payment method types? There's lots and lots of breadth at when that's going to impact and have downstream impacts. And so this design step is super, super, super important. I think it was called governance. Maybe there's just different terms for this, but the design and review step of an API has been really valuable. And so I wanted to just, again, get really tactical and show some of those specific outputs and artifacts that we create internally that I think are kind of interesting. So we have a process called API review. This is a process that's staffed with engineers from across the company, and they are tasked with looking at designs and proposals for any addition to the public-facing API, and that includes anything that's going to be released in beta. And the reason we do this is because even if we're going to add some feature for maybe some specific customer, there's a chance that that feature will end up in the public API, generally available to everybody, and we don't want to have to, have two different implementations or have like, some big user using one feature and then everyone else using another feature or a different name for that feature. And so we have these docs. There's a strong writing culture at Stripe. It's not uncommon for us to write 20-pagers once a week and read several 20-pager documents once a week. And so this is an example of that. We have a document that is proposing a change to a payment links API where we're now going to allow query string parameters or something. Something that's kind of interesting that I thought was useful, especially in this like fully remote world, is this concept of a gavel block. Does anyone use gavel blocks in their documents? Okay, yeah, this was super interesting and weird to me when I joined Stripe, but I think it's actually really powerful. And that is that you get the list of stakeholders that are going to be impacted by some change or some document. You put them in a list at the top with checkboxes next to their names, and then you build this culture of if the stakeholder reads the document and has any concerns about the opinions or the direction of the document, they write a comment below their name, and then you can just use the comments in the doc to like go through a debate. What's really nice about this is there's no meetings, and it's also, it works globally. So you can have your team members from all around the world come in and chime in about their opinions about the document. These docs also have really interesting things like change logs for keeping track of any adjustments to the proposals through time. So this whole API review process, I think we can kind of skip through this a little bit, but I just wanted to go through the steps here and outline that we actually take this super, super seriously. One of the things that we do is we outline what's true today. How are developers solving this problem today? Even if we don't expose an API for it, they are solving the problem somehow, right? We want to build a tool and give them a product. The product is the API, right? And that product is going to be hired. The API is going to be sort of hired to do a job, but that job is already being performed likely today by some other thing. Maybe they've got some hacky solution. Maybe they're using some no-code tools to wire up, some really interesting webhook, I don't know, automations or something to get something to work. So we want to first document what's happening today. Are they using our API? Are they using some other APIs to do this? Then we will also want to go through and list out all the different things that this change is going to impact. How's it going to impact validations, webhooks, documentation, the whole list of downstream things that it might affect. Then we also want to outline all of the different possible options that we considered. So like early on in your career as a developer, right? Like if you can just get something working, you're happy. Right? You like find a solution to a problem, like, okay, great, that's good, it works, I'm gonna ship it and move on. But the more experience you get, you realize that like, okay, there's actually several different ways to do this one thing, and the way I did it last time was bad, and I learned that like it was bad because of X, Y, and Z reasons. I'm not gonna do that again, and so I'm gonna do it this new way. And as you build up experience over the course of your career, 10 years, 15, 20 years, you start to build up this library of all the things you should not do, and all of the reasons why you should not do it a certain way. And so as part of these design documents, we outline a lot of different options and potential solutions to the problem. So maybe we're adding a new resource to the API. Maybe we're adding new parameters or a new, even a new enum value, right, to the API. And we'll outline like, here's all the different options that we considered and why we chose not to do each of these different options. And what that does is it gives you tons of clarity when you have some final decision about like why you're picking a certain approach. And oftentimes there might be trade-offs that you have to make between two things, and there will be heated discussions, right? And then at that point you might have a real live Zoom call, or if we're so lucky today, a real in-life, whiteboarding session or whatever. But that I think is a really powerful use of this sort of document and this structure of API review. We don't get it right all the time. We definitely do not get it right. So if you go to the API reference for the Stripe documentation right now, and you look at payment methods, you'll see these 4 different resources, and all of them have, get, put, patch, delete, whatever. And all of these represent basically the same thing. These are all different representations of a payment instrument. They all represent something that you can pay with. And until just a couple weeks ago, every single one of these was needed for weird edge cases. And that's because 10 years ago when we started designing the API, we only really designed for cards. And then as the API evolved and we realized, oh, actually we kind of do want to do bank accounts. Let's add bank accounts. Then we're like, okay, we do want to add Bitcoin. Let's add Bitcoin. And then later we decided, oh, we need to remove Bitcoins. And now like, as you kind of expand globally, there's all these different payment method types around the world, and very few of them are like credit cards. Many of them are more like bank accounts. And so we ended up with this new abstraction called a payment method, which is what we use today. But this is just an example of how like, even though you might go through this process, you're still gonna end up with like cruft and bad decisions, and it's all okay as long as you're just trying to be as thoughtful as you can, and also trying not to break any user's integration. It's kind of like one of our goals. Implementation. Whatever, we go and implement the thing. That's it. Release. So the release process, this is where things get really, really exciting for me. So we have, for the most part, when we are releasing new features into the API, it might look something like this. This is just a PR where we're adding a new filter option for a list endpoint of a quote object. And this is expecting the ID of a test clock. Test clocks are this really interesting feature of the Stripe API where you can create this resource called a test clock. It gives you back an ID, and you freeze that test clock to a specific time. And then you can attach other API resources like customers or subscriptions or all of these other objects to that test clock. And then you can make API calls to the test clock's API to advance time. And that will cause like all of the different webhooks to trigger, and it sort of simulates as you move through time. Kind of an interesting thing. But what I just wanted to show is like, okay, we added this feature to the tooling that will add ultimately this new filter for the API. Great, you open a PR and CI yells at you. And CI says, hey, you just added a new public thing to the API, but you didn't generate the open API spec. So we're like, okay. Let's go back and run that script. So we have a script that runs that automatically generates the open API. This is the artifacts that we might spit out. So we actually have like several different versions of the open API spec that we're spitting out. Now, Arna talked about a bunch of different tooling. There's lots of different things if you're using Ruby on Rails or Django or Laravel or whatever. There's going to be some library that you can install probably that will spit out the open API spec and all of these files for you. When we started building this application using Ruby a long time ago, we did not use Rails. And so all of our tooling is like homegrown. But this is kind of what a nice artifact flow might look like when you're making anything public in your API. So as soon as a feature is available, there's a test that runs, checks to see if that public feature has been added to your open API spec. If it hasn't, it fails a test. You go home, you like run your script, it generates the open API. Cool, now you push it back up, and another test fails. And that test tells you, oh, you didn't generate the client libraries. So for about 10 years, we've had these official SDKs or client libraries. These are server-side libraries. And in fact, like most of our users integrate with the Stripe API using these client libraries. So they're going to use Stripe Ruby or Stripe Node or Stripe PHP, Go, Java, .NET. We have 7 of them. And for 8 of those last 10 years, we were maintaining those libraries by hand. Every single time a feature went into the API, we would go open 7 pull requests on these open source libraries to add that feature into the API. Surprisingly, that was done for like most of those years by one person, which is just kind of like mind-boggling. And three years ago or so, we started using the open API spec to generate our client libraries. One of the things that was one of our like early goals was that we didn't want to break anyone's integration. Ideally, we decrease the churn for our users as much as possible. And because most of our users are using these client libraries to integrate, we weren't able to use one of these like Swagger CodeGen or OpenAPI CodeGen tools to automatically generate. One of the reasons was we didn't want to break people, and so we didn't want like the shape of the client library to change too much. But the other reason was that we have some really like interesting features of the Stripe API that are not natively supported by a lot of these generators. For instance, we have this feature of the API where you can pass in an expand variable, or you can just pass in like the parameter that you want to expand, and that will return sort of like an expanded version of that object in the payload that's returned to you, rather than just that object's ID. So by default, you might get back a customer's ID when you fetch its subscription. But if you want to, you can say like, oh, I want to fetch the subscription and expand the customer. Then you'll get back the full subscription with like the whole customer object expanded in there. And so like that kind of feature wasn't really fully supported by a lot of the CodeGen tooling at the time. So we were faced with, okay, we want to break as few people as possible, and we want to add all these features like expansion. And there was even another set of concerns that we had around polymorphism. So we talked about those payment method types, right? We have card, we have bank account, we have source. Well, depending on how early you integrated and how your integration has evolved, there's a chance that you might get back different types of objects as you're retrieving a list of some things, or it might be related in one case to a card, in one case to a source. And so that was another thing that wasn't really easily supported by these generators. And so, okay, so at this state, we have our PR. We've gone through the process of running the script to generate the open API. We went through the process to generate our client libraries. let's take a look at those client libraries. So this is like the C# code at the very top. Then we have some TypeScript down here below. The middle one is Go. And you'll notice that another thing that we really liked about our client libraries that we didn't want to lose was that it was like very opinionated about the style. We want it to be really beautiful. And for developers, when they open, if they happen to open the source, we want that to be like another very delightful experience. And so we were super intentional about like how everything was laid out. We didn't want it to be machine generated. We didn't want it to look machine generated. We want it to be sort of artisanal. And so this is kind of the output that we might see. After this PR is merged and everyone is happy with this new thing that's been released, we have a Slack message that pings us. And this is to kick off any of the things that we don't have already automated. For instance, we take the Open API spec and we run it through a different generator to spit out a Postman collection. We also use the Open API spec to build a mock server called Stripe Mock. So if you're building your own testing, you can use this Stripe Mock server to test responses and make sure that your code is behaving as expected against that mock. We also use the Open API spec then to update all of our documentation. So if you go to the API reference for Stripe, all of this code, the responses, the actual code that's there, that's all generated from the Open API spec. So this is all sort of like built in-house, but the tooling is all built in-house using React, and then it just consumes the Open API spec as JSON and is able to build out all of this stuff, which is pretty exciting. Now there's tons of tools out there already for plugging in your Open API spec, and it will kind of like spit out documentation that looks somewhat like this. But something that's really interesting that I think we've benefited from a ton, and we recently announced that we've open sourced MarkDoc, which is the framework that we use to build our documentation. One thing we've benefited from a ton is this snippet here, or this sort of MarkDoc component, which takes in some arguments that look sort of OpenAPI-y, or you could sort of think of them as different pieces of how you might reference parts of the OpenAPI. We pass in a path, method, args, and this small code snippet here is what we use to automatically generate all 7 code examples for curl, and examples for the Stripe CLI. And this is actually pretty amazing. And it's amazing because it's not just using like a requests library to show you how to do the Python example. It's not just using the fetch to show you the node example. It's using the client libraries, the SDKs that were also generated from the Open API spec. So you get this like really rich experience inside of the documentation, inside of the SDKs, inside of like the full sort of like path as you go out using the Open API spec. We also generate, as I mentioned, the Postman collection from the spec. So that's all part of that pipeline. All right, so that's where I was gonna end. How are we doing on time? If we're good on time, then I'm just gonna keep rocking it. I think we're good on time. So I'm just gonna keep going. So this is part 2, and this is what I'm like super excited about. For that release process and for building those snippets, I wanted to talk about some of the internal tooling that we have that we've never shared publicly. And I think it's like kind of mind-boggling, and it's really exciting stuff. So has anyone written React code? Okay, like a lot of people have written React code. And React code uses JSX, this like templating language, right? So JSX spits out, like ultimately it's spitting out some HTML. And that HTML, like it renders into your DOM and lets you do cool things with the DOM. The nice thing about JSX is that it's this templating language that has the full power of JavaScript. And so when I first saw it in like 2016, I was like, this is so gross. I don't like having markup inside of my JavaScript. Like, why are we doing JSX? I don't get it. But if you think about what JSX is doing and how it's spitting out HTML at the end of the day, there was a leap that I had to make. And this is a leap that I'm hoping you all will make with me, and that is that like your JSX can write, you can use your JSX to write other stuff. You can have it spit out other stuff, including programming language code. And so our code gen looks something like this. So we might have, the only reason we import React at the top here is just so that we can have JSX support inside this file. we have this prettier, we call this library Prettier Poet. I don't know. I'm really, really hopeful that we'll open source this someday. But notice that we're importing Ruby there. Ruby is sort of now this namespace for the Ruby programming language, but it's going to give us a set of components that let us render Ruby code. So here we're saying we're going to create a new component called Say Hello Ruby. It's going to take in a message, and this is going to be built with the component Ruby method call. It has this callee, it has some options around whether or not we want parentheses, and some arguments. Now we can build this little helper method that all it does is really render out to string. So now we can call this is using JavaScript. I mean, like really we wrote it with Flow, but everything is being moved over to TypeScript, whatever, it doesn't matter. At the end of the day, we wrote some JavaScript that is gonna write some Ruby. And so now it puts hello world like this. But like this is almost it. This is almost what we want, but it doesn't have the quotes around the string. And so let's improve this a little bit. So now we're gonna say, okay, we want this Ruby method call, but instead of just taking in some raw arguments and like having those at the end, let's make the argument that's coming in, we're gonna use the ruby.string component, and we're gonna wrap that up, and now that will spit out puts hello world with the strings around it. Super cool. I don't know, this like, just that alone, when I saw that, I was like, what? This is wild. Okay, all right, so now we can actually swap out the string with this other thing called a literal. And the literal just knows how to handle all kinds of other stuff. So now we can say hello 42, and it's gonna print out this puts 42, and it still works with our string of hello world. Magic. It's like, whoa, you can write JSX that spits out. Yes, it's so cool. So, all right, let's like keep going. So we wanna add a JavaScript component now. Now we're gonna use JS, right? At the top, we're importing now Ruby, and also JS, right there. Now we're building this new say hello JavaScript function at the bottom. Similar to how we had a ruby.method call, we now have a js.method call for printing out something to the console with JavaScript. We want to say console.log. We don't want to say puts. So we change the callee, we change some arguments, and now we can extend that to build out this new function where we can pass in the language and a message in a really, really sort of like abstract way. And now we can get either the JavaScript version or the Ruby version. And if you extrapolate this out, we can use this to build out literally like anything we want in tons of different languages. So now we can say hello, and we can pass in JavaScript, and we get our little console log. Okay, but if you notice there, it didn't have a semicolon at the end. We love our semicolons in JavaScript. I actually don't, but I don't know. So in order to get the semicolon, we can use another component called a statement. So JS statements here. Wrap our entire method call inside of a statement, and now we have a semicolon at the end. All right, so going all the way back to that example where we have our OpenAPI spec flow in, and that's gonna generate our client libraries. So we're taking that OpenAPI spec, and that is being used as the data that is backing our templates that are being rendered out as code. So now we're building these code gen tools that are just taking in the OpenAPI spec as JSON, and then we're using these templates that we're building with JSX to spit out all of our client libraries. I think it's pretty cool. So this is the actual implementation inside of our C# code gen that is just for that property component that will spit out that property. So we're gonna like look and see, is it, we have some like special cases here for whether or not it's a date time. And then at the end of the day, we are ultimately just spitting out this C#.property. We can tell that it's public, and ultimately we're just like giving back those 3 lines of code that are gonna be put inside of our stripe.net client library. So that is CodeGen. I'm hoping that you can sort of like connect the dots. That was like, here's hello world, and here's like the end, and then I'm just, yeah, you can make your way in between those 2 dots. So hopefully that inspired you. Hopefully that gave you some ideas. I think this is like some of the interesting things that Stripe is doing in terms of our API development and landing features. Thanks so much for listening. Are there any questions? Yeah, so the question was, can we talk more about deprecation that we talked about earlier in the talk? Why did we move away from it? And why was it painful? So technically we do deprecate APIs, but we don't end of life APIs today. So for instance, if you integrated with a 2011 API version and you are passing that version header for all of your API requests, your responses are going to be shaped the same as they were in 2011. And what makes that really difficult is in 2022, when we're trying to add a new feature to that API that you're using, now all of the code that we add and have added for the last 10 years all has to coexist, right? And so maybe you can imagine there's like a switch statement that's like, okay, if they're on the 2011 version, give them this thing. If they're on the 2015 version, give them this thing. If they're on the 2029 version, do this other behavior. And so it just makes it so that you're actually maintaining all of this cyclomatic complexity for every single like explosion of permutations of past choices and past API decisions. And so I would say like one thing that we could improve inside of like our governance structure is a legit process for deprecating and end of lifing old APIs and encouraging people to move forward, giving tools for people to move forward. So just like that's less of like a, it's more of like just kind of like a cautionary tale in my experience from the way that we've sort of built things. At the same time, there's a lot of benefit to that because if you integrate it in 2011 and you just let it run, then you're happy today because things are continuing to work. There was another question over here. So the question is like, what do you do if you need to if you need to rush a point, like a proof of concept, and you just want to get something out the door as fast as possible? We still have all this ceremony, and how do we get through that ceremony, in a quick way? So there are ways to expedite it, and we have like the team of reviewers that are on that API review is really big. So there's whatever, like it's massive relative to the organization, and so there's people that are sort of not on call, and it is sort of an annoyance to the team if they have to rush something through, but we can still have the same discussions and the same thought process, just in an expedited way. And we're releasing the API like several times a day. So it's not unheard of to be like, okay, we need to make this change. Let's talk about it today and release it tonight. That has happened. So, yeah. Yes. So when I say we're releasing every single day, this is a great question. So the question was, if we're releasing the API several times a day, how do developers deal with that? Do they have to upgrade? How do we tell developers that they need to upgrade? The answer is that every time someone integrates, they're locked into a specific API version, and when they integrate against that version with their specific like SDKs, the shape of that API is only going to be changed in additive ways and in non-breaking with non-breaking changes, unless we release a major version, in which case, if you integrated before, that's not going to impact you. And so we have a change log and we will tweet about it, but we're actually like, that's an area that we definitely need to improve, is like telling people, hey, there's a new API version, here's all the cool stuff that's included in it. Another thing that we need to improve for sure is our change log that shows every single additive thing that you could take advantage of. We don't do a great job of that. Instead, we're just releasing and updating the API in additive, non-breaking ways every single day, and people just don't know about it, and it doesn't impact them. unless they want to adopt one of those new features and they just don't know about it. So, yes. How many people maintain the API documentation? So for the API reference that shows all of the content there, that's not really, there's not a ton of maintenance. In fact, like all of that is auto-generated. If we're talking about the guides, like the long form integration guides, we have, I think the team now has grown quite a bit. I want to say it's like 30 docs writers, probably more than that, but we also have a team of product engineers that build all the components for the docs. Some really, really neat things. If you haven't seen the integration builder, you can sort of like, as you're scrolling down, it'll highlight different parts of code and explain what everything is doing in like the full context. So there's also like really interesting graphics and explainer charts in the docs that are all built with MarkDoc components, so they can all be like localized and all the different nodes and edges can be used, but also like changed to tons of different languages, which is like super neat. So, all right, I think I'm gonna hang it back to Ian. Thank you.